All right, we're looking at the solids unit, our Edpuzzle here. So we'll be doing some questions with you, and then you'll be trying some on your own. First, we have a prism. And so let's write out the formula for a prism. So the volume of a prism, it'll be a little neater if I write it here, is the base area multiplied by the height, the prism height. So in our diagram here, let's identify our base. This would be the base. Oops, don't want that. So this shape here would be the base. And it is a 7 by 5 rectangle. That's at the bottom there. So we would want to multiply 7 by 5, and then we would want to multiply it by the height. And it looks like it is, in terms of our height, 7 units for the height as well. So this piece right here, it's a little harder to see, but this is the height. That is 7 units. So for volume, we do area of the base. So the base we said was 5 by 7 multiplied by the height, which is another 7. Okay. So for volume, that would be here 5 times 7, which is 35. And then we would multiply it by 7. And we'll get our total volume for this figure. So 35 times 7, this would be 245. And for units, we would say 245 centimeters cubed. Okay, so a shortcut for a prism, a rectangular prism, which is what we have here, a shortcut for that would just be doing length times width times height. So multiplying those three things out. Okay, go ahead and for question 2, find the volume of this prism. All right, on to question 3. This is still a prism, so we are solving for the volume of that prism. So we want to know the base area times the height. I'm just going to take this formula, bring it down here. It still applies. The only difference now is that our base is a pentagon, and it is a regular pentagon. This right here is the base. And we know it's regular because the bottom has a top, the base, there's 2 bases, and there's all these congruent marks here to show that they are equal to each other. So those sides are all 10. Okay, so we got to find the base area. This right here is the height. A height is the distance between the bases. So I'm going to put h next to that for height. Now all we have to find, so this is going to be 12 for this case. Now all we have to find is our base area. Well, base area, area of a polygon, area regular polygon, I'll just write polygon though, but it works for area of a regular polygon, remember is a side length of the polygon multiplied by the height of the polygon. We also call that the apothem, times the number of sides that you have, all divided by 2. Let me move that over just a little bit. There we go. All right, so let's find the area of that pentagon. So our area of the pentagon, or we'll call it base area, is equal to, well, the side length of the pentagon is 10. The height of the pentagon, this length here, we also call it the apothem, that's 6.9. And there are 5 sides, so times 5, all divided by 2. All right, so let's multiply these out. We've got 10 multiplied with 6.9 multiplied with 5, all divided by 2. So our base area for this shape is going to be 172.5. And for volume, we need to take that base area and we need to multiply it by the height. Well, the height of our shape we said was 12. 172.5 times 12. So that's going to be 2,070. And that's going to be inches cubed. Okay, go ahead and solve for question number 4. Okay, now we're looking at pyramids, and we're the next one. And the volume of a pyramid, volume is base area times pyramid height divided by 3. So if you remember from the video diagrams that we saw, when we poured the contents of a pyramid into a prism of the same base and height, we could fit 3 of them in there. So that's why it's divided by 3. So what we do here, this is a square base. So let's find our volume. Our volume is going to equal our base area, which is 8 times 8, or you could just put 64. Our height of this pyramid is 9. And that's all going to be divided by 3. So our volume will simplify to, let me clear all of these. We've got 8 times 8. If you want to just put 64, that's fine as well. And we're going to multiply that with 9, and we're going to divide that by 3. So our volume for this one here will be 192 yards cubed. Okay, go ahead and find the volume for question number 6. And in question 7, our volume is still the same. It's still a pyramid, right? So we are going to do the base area times the height divided by 3. The only difference now is here we had a square for the bottom. Now we have a rectangle for the bottom. So it's going to be 11 by 7. So our volume in that shape is 11 by 7 multiplied by the height, which is 11, all divided by 3. So we're going to put that into our calculator. Instead of 11 times 7, you could just do 77 times 11 divided by 3. So if we're rounding this, I think it said nearest hundredth, which is 2 places. This would be 282.33. Don't worry too much about the rounding. Miles cubed. For the test, I would accept answers like I would have accepted 0.3, that's fine. 0.333, that's fine. Or if you did 1/3, that's also fine. Okay, go ahead and solve for question 8. Okay, our last pyramid here that we're solving for the volume of. So formula is still the same, base area times height divided by 3. Okay, this is the height, that's the 11, it's the height of the entire shape, but what we need to figure out is the area of this hexagon bottom. This is a regular hexagon. So remember, a regular hexagon or polygon area is equal to a side length of the polygon multiplied by the height of the polygon, or we'll call it the apothem, multiplied by the number of sides divided by 2. That would be the base area here, or polygon area is what we're calling it. So our side length of the polygons is going to be 7. The height of the polygon at the bottom, it's the height of the base, which is kind of confusing. It's not 11. It's this piece right here, the apothem. We'll say it's 6.1. This has 6 sides. We'll divide that by 2. So we'll multiply 7 with 6.1 times 6, all divided by 2. So our volume for this shape, our area for just that bottom piece is 128.1. Now for volume, we need to, volume is base area times height divided by 3. So our volume is going to equal, well, we got a base area 128.1. Our height 11 divided by 3. So we're going to take 128.1, we'll multiply it by the height 11 divided by 3. This would be 469.7. And that's inches cubed. Okay, go ahead and answer question number 10. Okay, and our last two shapes here, we've got a cylinder and a cone. For a cylinder, our volume is pi times the radius squared times the height. So in this diagram, 14 is actually the diameter. So that means our radius is half of that, it's 7. Our height is 10, and I'm just going to plug those two values in. So our volume is pi times 7 squared times 10. Now I'm going to show you how to put your answer into two formats. So our volume is going to be pi times 49 times 10. 49 times 10. If I were just to multiply these two and I leave it in an exact format, I'm going to get 490 with a pi after it. But I do want an approximation because we're rounding these to the nearest two decimal places. So 490 pi is what I would want to put into my calculator. Actually clear all these off. So 490 and then type the letter pi after that. So this is approximately 1,539.38 feet. So how you put this in the calculator initially, if you just did the 7 squared times 10, that would have given you 490. But if you put pi in front of it, that gives you the answer already in what we call approximate form. So we'll just say this is the exact form where we leave pi in the answer, and this is the approximation. We rounded the answer. Okay, go ahead and solve question 12. Okay, and with our cone, the volume between a cylinder and a cone is similar to our prisms and pyramids. It's just divided by 3 essentially. So we're going to do pi times the radius squared times the height, all divided by 3. So our radius in this diagram, that's easy, it's 4. Our height in this diagram is 11. So we'll just plug those in. So pi times 4 squared times 11, all divided by 3. So I'll show you what we can put into the calculator initially. We're just going to put 4 squared, and then we're going to multiply out by the 11, and we're going to divide by 3. Now, if I took that same thing and I put pi in front of it, that would be my approximate answer. So this is kind of weird because typically we don't put decimals in front of pi, but this is what the exact answer would be. So just these pieces multiplied by each other, that would have given me 58.6 repeating pi, or technically 68 and 2/3 pi. That's probably how it would more properly, we would write it, 58 and 2/3. That's 0.66. You can also put 0.67 pi. But that's why we sometimes also do an approximation, because it's not clean to put decimals with pi in front of them. So our approximation for that would be 184.3. 0.30 would actually round to 31, and this would be miles cubed. Okay, go ahead and solve for the volume on question 14. All right, and then our last set of questions, we are looking at surface area of some figures. Okay, so for surface area, you are finding the area of every side, and we are simply adding them all together. okay? So essentially what you want to do is basically for a rectangle prism, there's a front, a back, a top, a bottom, a left, and a right. So you're really going to multiply each set of numbers with each other in a combination. So we've got the numbers 6, 7, and 9. So that means one of my sides is going to be 6 times 7. We'll put what that equals in just a moment. Another side is going to be 7 times 9. And then another side, our last combination of two numbers would be 6 and 9. And I'll show you what each of these represents on the diagram. So our 6 times 7, that would actually be this piece right here, 6 by 7. It looks like it's actually the top piece. And 6 times 7, that is 42. And then we have our 7 times 9. So that's going to be this piece right here on the right side, 7 by 9. And 7 times 9 is 63. We would have two of those pieces, the right and the left. And then we had 6 and 9, and that's actually this piece right here, 6 by 9. That's the front piece. So really, when you have rectangular prisms, you can just do a combination of all three numbers multiplied out with each other. So 6 by 9 is going to be 54. So for surface area, we add up all of the sides. You can do a little shortcut to that. So let's see what we would put in our calculator. You could technically do 42 plus 42 plus 63 plus 63 plus 54. Add up all the sides. A shortcut could be two of the 42s. You've got two of the 63s. And you've got two of the 54s. Oh, and this is gonna, I didn't do two 54s up here. There we go. So 318 would be the total surface area. And another shortcut, even if we want to do one last shortcut to make it even simpler, is basically if I take all of three of these numbers and I add them together and double it, that would be like probably the easiest shortcut. So I would add 42 plus 63 plus 54. And if I said, oh, well, all of those need to be doubled, so I'm going to multiply all by 2, I would get 318. So either way, any way you do it, you're still going to get the same value. So I'm going to get 318, and we'll say centimeters squared this time. Okay, go ahead and find the surface area for question 16. On question 17, we are going to need to find the area of the bottom piece. That is a hexagon, and then we're going to need to find the area of all of the rectangles. So let's first do the hexagon area. Remember, hexagon is equal to the side length multiplied by the height of the hexagon multiplied by the number of sides divided by 2. And remember, this is kind of like another term for that apothem. And that's because I don't want you to get confused with this being the height of the whole entire shape, the hexagon height. Okay, so let's find the area of the hexagon. It is the side length would be 7s. All of these are going to be 7s. We know they're all equal. The height would be this 6.1 here, or the apothem. The number of sides, it's a hexagon, so there are 6 sides divided by 2. Let's clear out this calculator and let's put in 7 times 6.1 times 6 divided by 2. This looks familiar. I think we had this exact hexagon, but in a, we're finding volume. So we have 128.1. That's the area for one hexagon base. Now we have 2 of those. So that's this piece down at the bottom here. Also this hexagon up at the top here. So for surface area, we're going to add all of them together. So we have 2 of those pieces, the 128.1. And then we also have some rectangles. So we have 2 hexagons, so surface area equals 2 hexagons And we have 6 rectangles as well. So like this rectangle here. This rectangle here would be 11 by 7. So 11 times 7 is 77. So we've got 6 of those, 6 rectangles with an area of 77. I'm running out of space to write my volume here. So the volume, when I add together all of those pieces, it's going to be 718.2 miles squared. Okay, go ahead and find the surface area for question 18. On question 19, we are finding the surface area of this shape. So we have one, it looks like a square. That's our base, one square base. Let's find the area of that. That would be 6 times 6, or 6 squared. So that is 36. And then let's find the area of one triangle. Now, if you wanted to lay this out flat, one of the triangles would look like this. We'd have a 6 here, and it looks like this is pointing to 6.7 here. So one triangle, remember, a triangle is base times height divided by 2. So it's 6 times 6.7, all divided by 2. So let's figure out what that is. It's going to be 20.1. So for the surface area of the whole shape, surface area equals one of the bases plus 4 triangles. Let's put that into our calculator. So we knew the base was 36, and then we have 4 triangles, and each of the triangles was 20.1. So our total surface area is going to be 116.4 yards squared. Okay, go ahead and find the surface area of number 20. Okay, we're going to find the surface area for these prisms here. I'm not going to write the formula out again, but we're going to find the area of the pentagon. And remember, I'll talk you through the formula. It's the side length. So each of these pieces here, side length is 8, multiplied by the pentagon height, 5.5, also known as the apothem, multiplied by the number of sides, 1, 2, 3, 4, 5, divided by 2. That's the area for the bottom piece. So let's figure out what the area is for that bottom piece. We've got 8, and then 5.5, and 5 divided by 2. So it's 110 is the pentagon. And we'll just put that here, equals 110. Now we also have triangles. We have 5 of them. So this would be like an example of one of the triangles. Remember, a triangle is base times height divided by 2. Well, the base is this length here, 12.3. Oh, I'm sorry. No, the base are all the side lengths, 8. Base is 8. So let's do triangle equals. Let's find the area of that. So triangle is base times height, so 8. And then the height, that's this length right here, the slanted height. That's the height of all the triangles. So 12.3 divided by 2. And that would be the area for one triangle. We've got 8 times 12.3 divided by 2, and that's going to be 49.2. So our surface area, we've got a pentagon and 5 triangles. So we're going to add those all together. So our pentagon had an area of 110, and we're going to add to it the 5 triangles, and each triangle was 49.2. So our total surface area is equal to 356 kilometers squared. Okay, go ahead and find the surface area of number 22. On to our last two shapes, our circular shapes. So surface area, we have our formulas. If you remember when we are looking at a cylinder, if you were to lay this out flat, it would be a rectangular piece with the two circles on the top and bottom. Let me draw that out a little neater. And our circles. So remember, an area of a circle is pi r squared. So let's write out our surface area formula. We have a pi r squared here, and we have a pi r squared here. So it's going to be 2 pi r squared. We have two circles. And then our other area, this is the height here. So a rectangle is base times height. Now, this other piece, this part here, the base of this rectangle is essentially the circumference of this circle, which is 2 pi r. So when we multiply those two things, that is our area for that rectangle. So we would say 2 pi r times h. So this is the two circles, this is the rectangle. Okay, so we're going to plug our formula or our information in here. Our radius is 4 because the diameter is 8, and our height is 9. So we've got 2 pi, let's plug in a radius here, and then we've got 2 pi, a radius, and a height here. So our radius, we're plugging in 4, and our height, we're plugging in 9. And this one, we're leaving pi in our answer. So we're not multiplying it out. We don't need an approximation for that. So when I put this into the calculator, it's going to be 2. I'm not going to write pi because that would multiply it out by pi, and we don't want to do that. 2, and then we're not going to put the pi, but we're going to put the radius and the height. Oops, I have an extra one here. There we go. So this will be the radius squared. This is where r goes, the radius. This is where our radius goes, and this is where our height goes. So we have 2 pi times the radius squared, so we're just doing 2r squared, everything but pi. And then we have 2 pi r squared, so we're doing 2r, or 2 pi rh. So we're doing everything but the pi. So let's replace the radius with a 4. Let's replace radius with a 4 and a height with a 9. That's going to simplify to 104. And you can do each of these pieces individually, but since I'm doing it on a calculator, I just kind of did it all together at once. So 104, and don't forget to put the pi after it, and that would be feet squared. Okay, go ahead and find the surface area for number 24. And then our last question here, we have our cone, our surface area. Remember, the bottom of this is a circle, so pi r squared. And then we also have the sector of that, which is pi times the radius times the slant height. So our radius is 5. Our slanted height, that's this one here, our slanted height is 12.1. We're just going to plug those into our formula. So we've got pi, our radius squared, plus pi times the radius times the slant height. So our radius, we'll put 5, and then 12.1. So when we are putting this into the calculator, we're going to put everything except for that pi. So we want the radius squared, pi, and then we're leaving pi out, radius, slant height. This is where we would put the radius. Let me erase this formula, that's from before. This is where we put the radius, this is where we're putting the slanted height. So our radius is 5 in this case. Our radius, we'll put 5 again, and then 12.1. This would simplify to 85.5 pi centimeters squared. Find the surface area for question number 26.